Hello, everyone. I realize we're starting a bit late just for technical difficulties here. So it's good to see you all. And what I would like to do, first of all, is just to give you a brief idea about what I'll be talking about today. So if you're interested in this topic, maybe, or if you have any question, I'll be staying around after this session. So drop by and say hello, and let's just discuss a few things about this important topic, basically. So my name is Fawaz Ghali. I am the developer advocate for a company called Hazelcast. And what I'll be discussing today is best practices for real-time machine learning. So I realize that we all come from different backgrounds. So obviously we don't have the same experience level. So some of us are really good at, I don't know, software engineering. Others are good at data science and DevOps, business, and so on. So what I wanted is just to give an overall for this topic because it's quite important. It's not only touches your career, but also like you interact with this specific topic on daily basis. So whatever you can gain from this topic, it would be good if you can just try it out and see what we're talking about today. The keyword on this screen is not machine learning, or it's not the best practices. Obviously, we will discuss these things, but the key word is the real time. And real time means different things for different people. So I don't know. For some, it might mean things happened yesterday or the week, before, or even like a couple of hours ago. But what we're talking about is really fast data access. So these are a couple of examples we're looking at here today, kind of like it's just to give us what we're talking about. So anyone can guess how long it takes for an eye to blink? So it takes roughly around 1/3 of a second. So that's pretty quick. If someone wants to collab, for example, that takes like 1/7 of a second. And if you have like a camera and use some kind of flash on this camera, it takes like 1/1000 of a second. So these kind of like applications are quite fast. It's not possible for a human eye to know what's going on, basically. So what you need to deal with is kind of like a speed process. And you might think about it is like you can write a software to handle this, and that might be true. But the problem it comes when you scale your application. And if you want to scale your application, you probably need some kind of mechanism which allows you to handle not only like seconds, but also it drills down to milliseconds or even sub-milliseconds. So you can see this everywhere, basically. So for example, financial institutions use some kind of machine learning in real time. We have also Internet of Things, mobile devices, GPS coordinates, or even cars. Any IoT device use some kind of real-time processing. We have hospitals, for example. Sports use this to predict some kind of outcomes in real time. And also, this is where we're talking about the AI and machine learning. And obviously, what you're looking at is not only how you can get the best algorithm right, because if you come from data science background, you might be interested in tweaking your model and making sure that you have the perfect model for a specific scenario. And that might be true, but it doesn't work if you want to scale it. So what you're looking at is some kind of secret sauce for this. So hopefully I will give you some idea where you can get started in best practice for real-time machine learning. Essentially, if you want to get success, it's not only about how fast you can process your data or how good your model is. It's kind of like a combination between the two. So I know some people spend so much time on creating a really strong machine learning algorithm just to make sure that they hit the target for various scenarios. And it works when you develop the model, but when it comes to deploy it, and especially if you want to scale it up or down, it's kind of become bottleneck. So you're not interested anymore with the perfect model. What you want to make sure is to get the high performance combined with your machine learning algorithm. And obviously, we're not talking about like, I don't know how many people are here in this room, but we're not talking about like, tens of transactions or even like thousands of transactions. We're talking about like 20K, 30K transactions per second. And this is really fast. You can't really have a program which can run on maybe like a few hundred transactions, and you can use it for this type of applications, especially if you want to scale your machine learning model. So what you want to make sure is not only to hit your target on small scale, but also at the same time, you want to be able to scale it, right? And some of you might suggest the solution to add new hardware to your infrastructure, but it becomes not cost efficient because, for example, I will show you some trends where things spike. For example, I don't know if you have here a Black Friday event, for example, so where you can get like online sales spikes and so on. So this kind of like you want to make sure that your application is dynamic or adaptive. Basically, you can scale it up and you can scale it down, instantaneously. And obviously, you want to not only look at this. So some of you might now be questioning, why do I need to care about this? Why my application needs to care about how many transactions I can handle in real time, or even why I need high scale capabilities? And the answer comes from these figures here. So if you're coming from industrial background or from an industry, you're probably looking to save money. So for example, we have specific cases for using a real-time machine learning for fraud detections, and this kind of like saves like around $100 million per year, which is quite big amount. So if you want to, think about it, what type of also, not only about money value, but also how you can make your application run fast. So you can look, for example, 20 times faster, so between 2 months, for example, to run a specific algorithm, or for example, we're talking about hours or even minutes in some specific cases. Also the performance itself. So if you have, for example, a benchmark for your application, so you want to make sure when you scale it, scaling doesn't mean only about compute, but also about data. I will explain what I mean in a few seconds. But essentially, you want to have some kind of improvements, right? So after all, not every application will perform the same. And if you have two applications that handle the same amount of data, you probably end up using a faster application, essentially, because that's where things can change dramatically. And because what I want is like you to leave this room thinking about a real use case. So I thought that maybe because this is like this use case I will be discussing today touches every one of us, so perhaps it's a good topic to discuss, but it can be applicable to any domain, basically. So I will be focusing on the machine learning in real time for fraud detection. So this is a quite important and hot topic. So now we all have credit cards, debit cards. We use our mobile apps to do some kind of payments, or we use internet and even ATMs and so on. So it becomes really complex to handle it. And I don't know any bank or any financial institution who doesn't use some kind of machine learning and in real time. So remember, we're not looking at historical transactions. So I'm not looking for what happened in my account like 1 week ago. I want to basically, if someone is using my card now, I would like to get some alerts now. I'm not interested if someone hacked my account 1 week ago, because that doesn't give the purpose. So these are a couple of examples here just to get you in the mode for real-time fraud detection. So duplicated testing for machine learning is essentially, say for example, you have a specific payment. So I don't know, maybe your internet provider, you send it once a month, or maybe your Netflix subscription, you send it once a month. So think about it if you have a specific transaction on your bank account. So what fraudsters do, they actually try to basically duplicate the same transaction so you don't notice it, or even your bank doesn't notice it. So they will use the same amount, whatever the amount is, they will use a specific information about your account, and they will try to replicate it. So whenever you see it, instead of saying today we're on 27, so imagine that you have like this payment on 27 and you saw it in 26. So if you saw it yesterday, you probably don't investigate it much, because you will say, for example, this is Netflix payment or my internet provider. So what I will be doing, I will just forget it, because It's not happened on 27, it's happened on 26, and 26, like, it's not big deal. Pattern detection is another example where you can use machine learning for fraud detections. Essentially, if you look at your bank account, we all have the same pattern, basically. So towards the start of the month where we get our salaries, we see kind of spike in the account balance, and this account balance start to decline over month period. And this is kind of like a pattern, so, or even around Christmas time where you have more spending and so on. So fraudsters use this to replicate the pattern. So they check your account and they try to do some kind to replicate this pattern. And obviously the machine learning algorithm should be able to handle this case. Account scoring is kind of like, I don't know what's called here, but it's credit score. So essentially, if you, for example, try to apply for a loan or a credit card, your bank account will check your application based on your history, and they will give you a score. And this is the demo for today, so I will be discussing this exact point here. And also identity theft, so someone else pretends to be you, use your account for some reasons. And reduce false positives is quite important. So for banks, generally speaking, they don't want you to spend your money somewhere else, right? So imagine you have two bank accounts, and one bank account declined your payment for whatever reason multiple times, and even it is like valid transaction. So you probably end up using the second bank. So we all have like favorite bank. Favorite bank means they know us, basically. They know these are our transactions. And reducing false positive means essentially your card will be declined even it's valid. So even it is valid transaction. So what you want from your real-time machine learning algorithm is to reduce it, to make sure that we don't have false positives here. And if we look at it, drilled it down to a specific case where we discuss credit cards in general. So usually you have time-based SLA where you need to handle your request. And imagine that's your card on one side here, and basically you're trying to do some kind of online payment or shop payment, whatever. You send your request to your bank basically through specific infrastructure, and they will check if it is valid or not, and they will send response whether yes, accept it or not. So if you look at it as it stands, it might be simple. So you might be able to handle it like in your infrastructure, but there is a good side of this story and not so good side of it. So the not so good side of it, which you cannot do anything about it, is the time you spend traveling. So for your transaction, so from you swiping your card, checking back account and coming back, this is where things can actually have a performance or latency issues, and simply you can't change it because you will have some kind, I don't know, network hoops or cloud infrastructure. You want to send requests over like a cable or whatever infrastructure you use. So this cannot be changed. What you can do is in a small time frame, we're talking about milliseconds and sub-milliseconds, so pretty fast. You want to make sure you not only to write your machine learning algorithm, but also to run it. And if you have, I don't know, 1,000 requests from one side, your application should handle it the same way it handles 100,000 transactions in the same time frame. So this is kind of like where you need to spend your time. So this part here is what we were talking about. So everything else we can't change simply because it's infrastructure, hardware infrastructure. So just to give you an idea how much time you lose, basically, if you look at it, so this is where the transaction appears. So it's easier if you track the color scheme there. So the Viridian color is essentially, let me check here. So we have the authorization. So if you just follow the Viridian, you can see how it goes from merchant to payment gateway to your bank account. It checks it, and then you get a response back in the orange color, purple color, just to clear it and settle your balance account. Usually second and third steps happen at the same time, but it varies from one bank to another. So we're not worried about it too much today. What we want to make sure is to understand its very complex infrastructure. in terms if you want to build architecture for such application. And to add a new level for complexity, it's not one way, right? So it's not only my card, it's not only my mobile, it's not only my laptop, it's not only my ATM or going to the bank account. So all these channels you see it on the left, all are working in real time. Obviously, this is just for one user, so you can imagine, I don't know how many we have here. So you can imagine how it becomes really bottleneck to handle multiple channels and at the same time to handle different payment networks. So for example, it could be business to business, it could be foreign exchange. So I come from the United Kingdom where we use British pounds. If I want to use euros here, so I need to do some kind of, I don't know, foreign exchange and to get the euros, and it can be either like bank to bank and so on. So it becomes really complex, not only from how many people, how many channels we have from one side, but also how many parties are involved. So this Viridian box here is the main core element today. So the payment hub service, essentially what you can do. So the operational data store is not database, it's not a physical database. We're talking about some kind of data stored in your memory. So if, for example, I'm active user, I'm using my bank account multiple times, you don't want every time to access the database. What you want is to store specific information about my account in memory. So every time you basically access it in much faster way. So that's the operation data store. It's not a physical database. It's kind of more like data stored in memory. You have the authentication and fraud detection algorithm. And you also have the gateway where it's kind of like the hardware side of it. So the hardware, again, we're not discussing how you can optimize it, because however you optimize it, there is still bottleneck you can't overcome. And now if we look at this infrastructure using the platform, so this is very important figure what we're talking about. So this is our platform. It's called the Hazelcast platform. And the platform itself is built on multiple, let's say, components. You have, first of all, the sources. So sources means where your data is coming from, right? And in this case of real-time machine learning, so obviously your bank needs to know not only data coming, I don't know, from Kafka, if you know Kafka, or if not from messaging queue. So they want to know basically more information about you. So they can retrieve your bank details from here, from your, and store it in memory. But they still need, for example, I don't know, IoT data. So GPS coordinates, where are you located? Or where is your, the IP address for your network you're logging in from? So all this information becomes really important to handle it and process it. So you get sources from, and then you import it to the platform. We have a specific way to handle multiple sources, but it's important to understand whatever you do now in real time, you really need to have multiple sources. So we have something called fast data access for operational data store, where you try to gather as much as possible data and store it locally in memory. And we have the streaming processing engine. So the stream processing engine is important. So every time you hear about machine learning, for example, you would assume it will check some kind of data and it will predict the outcome, which is true. But in reality, you need much more than this. So the data is not only what is stored, what already exists. The data also happening to be arriving instantaneously. So this is where the data in real time can be combined with the data at rest or data at batch in order to provide some kind of real-time capabilities. Obviously, we use different languages, so we're not all using a specific programming language. The platform itself is open source, so you can try out my demo today. It will be available, but obviously you can use multiple languages. So whether it's Java, for example, the platform itself is built on top of Java virtual machine, but you can use various programming language, whether it's, I don't know, .NET, C++, Node.js, and so on. And also, if you're coming from data science background, you probably don't want to spend your time trying to learn a programming language. What you can do is use the SQL interface. So the SQL interface allows you to handle these requests in real time, so you can be able to to change the query and track it in real time. Obviously, once you're done handling the data, what you can do is, send it back. So do you want to send it back to Kafka topic? You can do so. Do you want to send it, for example, to some kind of alert? So if my card now is being used, I don't know, in the UK, I want to get some SMS. So it is possible to do all these output, or what we call it, syncs. And the machine learning part of it, where we can handle the data, is coming from two places. So the data is coming in Kafka topic or Pulsar or message queue. So these are transactions happening in real time, right? Remember, these transactions should be handled even before you store it to your data set or database. Why you need to handle it before you store it? Simply because you want to avoid latency. So what we're talking about is milliseconds and sub-milliseconds. So you don't have enough time, regardless how much hardware or how fast your hardware is, you still are limited with the hardware capabilities. So you want to handle these transactions even before you store it with the data into your database. So here you can write your machine learning model, and the platform where you can have the real-time stream processing will actually import this model. So you will have some kind of data engineers who will write models. And I say models, not model, because as I will show you, we need multiple models if you want to run real-time machine learning. Because one of the best practices for effective machine learning algorithms is to have multiple algorithms. And I will explain why. And this is the data where you store it. So you store the actual data, which is like, your transaction history, based on your bank account and your current transactions, and you can simply output the results, some kind of microservices. Microservices essentially allows you to write multiple pieces of software to handle multiple requests. So you don't end up with, like, I don't know, one class or one application with like 1,000 line of codes. What you in the like small pieces. So one piece for alert, one piece to check your balance account, one piece, for example, to combine between your credit score and your account score, and so on. So this is possible to do it. And the main reason for scaling the application and saving time is we want as low latency as possible, right? Because any latency we added to the application, any expansion, any scaling, you need to factor in how much latency you add to your application. So if you remember the sources from one side, so the sources from one side refer where data is coming from. So your bank account, your GPS coordinates, even the weather, for example. So now, for example, it's raining outside. So this can be also integrated within the machine learning algorithm. And you should be able to have some kind of platform where you can scale it up and down. So instead of spending, I don't know, 100K on infrastructure, and you don't know if you're going to use the 100K or 10K of your infrastructure. So you want also to save money. And auto scaling is a feature which allows you to add more nodes to your application based on how much traffic, how much data you're handling. But at the same time, you can scale it down. So for example, if you have a not so busy day, so you might not need like the 100K infrastructure. And the compute, there is difference between compute and data. So compute, we're referring to the process, your application, and the data refers to your data, basically. So database and real-time transactions. So everything you do, you need to factor in how to save on time. And one way to do it is to handle requests based on where the data is stored. So think about it as this is where your bank account data is on a specific node, and this is where your GPS coordinates are stored on specific different place. So this could be, I don't know, here in Porto, or this could be, I don't know, in the UK, this could be in the States. So you want to split your performance, your compute, as close as possible to your data. So it's very important because after all, if your data is here and you process it somewhere, I don't know, geographically is not the same where your data is. So you need also to factor in how much time to send your data and to process it. And when it comes to write the machine learning algorithm, obviously you can use different programming languages. Usually data engineers use Python, and that's quite popular, but in order to connect it, you need to make sure this kind of like the Python virtual machine, you can scale it based on how many nodes basically you have, or how many processors within your CPU and so on. So what you can do is initiate one instance and send requests to multiple instances. So if you have, for example, 2 inputs, so one is, I don't know, GPR coordinates, and the other one is something completely different. For example, your last 10 transactions. So what you want is to be able to, mix and match, because it's not only one way, it's like a combination between multiple ways. And this is where a benefit of using one of the benefits of using machine learning in real time is the ability to switch between your sources and your output. So sometimes you want to send the output or deliver your output from 2 processors here to your mobile device, for example. Some other times, depends also on the location. So if you have a bad internet connection, so you're probably not going to use your mobile, you might, I don't know, use phone, for example, even if you don't have internet connection. So you should be able to do this in real time as well. So real time again refers not only how you read your data, not only how you process it, but also how you output it as well. And one of the most challenging part, which most of machine learning models fail in, is they try to predict a specific outcome. So after all, machine learning is about prediction, right? So you get some data, you write some code, and you want some kind of, knowing what's going to happen in the future. And that's perfectly fine in a development environment. So you get your input, you try to get some kind of score. And one thing I always keep mentioning is it's not important how good your machine learning model is. Yes, obviously you need some kind of statistics for your model, but that's not the whole story, right? So what you want is to be, first of all, dynamic. So this model should be changed in real time. I will explain now when I get here. And also, you want to handle multiple models at the same time. So, which brings me how we handle it in Hazelcast. So this is where you have something called composite score. So you have multiple models running at the same time and the ability to change it in real time. So why are we talking about this? Why it's important not to use a hard-coded model or, the perfect model for fraud detection. So if you now go and search for, perfect model or best model for fraud detection, you get some results. If you try to use it, it will work. But if you, try to deploy it in production, probably it will fail. And some people think about it as a problem in their code, which is reality is it's not. It's basically how many you can handle, because trends change over time, right? So fraudsters usually, if you remember, one of the use cases is finding trends. And one trend is the dynamic of the application itself. So for example, if you have one algorithm to handle fraud detection on your mobile app, if you use online payment, for example, it works fine, but it depends also, again, what's happening. So if I'm spending more money on taxis or on Uber, this is a trend, right? So I used a specific machine learning model for this, so where it will predict what is best price for, my next ride, and specifically this. So it will take, my previous rides or previous Uber orders and handle it in one model. But at the same time, if I'm using Uber as well to order some food, that needs also a different model. And if I stopped or changed, so from Uber to a different company, for example, and it's the same thing, I either kept Uber Eats or used different companies. So these models change over time. So what is working now, there is no guarantee it will work after 10 minutes or after 1 hour. So this should be dynamic, and you obviously, because it's in production, which means you don't want to shut down your application. You want to be able to switch processors and switch processes as well. So your applications keep running 24 hours 7 without any downtime. And this is where the 99 or 5 nines, 99.999% availability comes into place. So that's why it is important to handle multiple requests. So this is where we need to check if what we're talking about works with large data. So now, of course, I discussed like 20K transactions, but even like 20K transactions per second isn't big. So what we try to do is kind of like test how many transactions can we handle in 1 second, and we managed to run 1 billion transaction. What is nice about this benchmark is the linear regression of how many nodes. And obviously, if you heard of Spark or Apache Flink, so you know that basically they have some kind of latency, so you want to decrease it as much as possible. And the parallelism also not only on the how many nodes, but also how many processors you have within the system. So if you're using basic REST, you might be able to handle 5. If you want to scale it using the stream processing engine, you might be able to handle it in 20K, or even you can scale it. So before I proceed to my demo, I just want to show you a real use case. And this use case is essentially how much time this client saved based on using real-time fraud detection. So as you can see, they managed to have 10% improvement, which is roughly around 100 million, essentially, just by following this best practice I'm talking about. So to proceed to the demo, what I will discuss is 2 demos. So the first one is how do we do it in real time? So this demo here it talks about if I am in the UK, in London, I want to use my card, it should be valid. If I travel to Frankfurt, which is like 2 hours journey, it should be valid. And essentially, if you send this request to your bank, you shouldn't have any false positive. Your bank should honor this process. But if I use, for example, the same process again, but instead of using Frankfurt, Germany, I'm using New York. So I know for a fact, definitely, it's not possible to use the same card in 2 different places where geography is not possible to have it in 2-hour window. And it might be easy, but if you look at it, how many flights we're talking about, how many people at airports. So this figure is like, I think 1 week ago I took it. So if you look at the black line here, we see how many flights. So we have like roughly around 250K per week. Now, if you want to multiply it by how many people on each flight, so these numbers become really hard to handle. So one way of doing it is to use the Hazelcast platform. So this solution is available online. You can try it out yourself. So we used AWS to deploy it. It takes the airport data in real time and it takes users' data in real time. It handles or imports it to the AWS. It does some kind of validation on it, and it sends it to Hazelcast Viridian. So the Viridian is a serverless service for you, which means you can sign up for this service. It's a free of charge. You don't even need a card details or anything, and you don't need even to worry about logistics. The platform will handle it for you, so you can deploy this model in real time, and then we do the import airport data and do the transaction. So I apologize if you're coming from non-programming language. So this is if you have some knowledge in JSON format. So this is the data stored in JSON format. And essentially, I'll just explain the code. But as I mentioned, the code is available online, and it's open source, so you don't need anything. You can just plug it, and so you connect to the Viridian cloud, and you import the airport data, which is stored in JSON file. And so once you import it, now your question might come into how do I do it? How do I validate the card? Essentially, what you can do, if you remember, we use the data coming from the airport locations, so GPS coordinates for airport. And if you know the speed of plane between, per hour, for example, you can calculate how much it will take time. So this is a simple condition, and you can write it, for example, in random forest tree, or you can expand it to use linear regression. So you can change the condition. So that's not important. What is important is the ability to scale it up and down to handle the data. And one way, so that's the first demo, obviously, but one way to, if we want to drill down is, so how do I, if you are software architecture, how do I build it? So you're not interested in code, you're not interested in data science, you want to build a robust or machine learning in real time. So the data for transactions, so think about it as your transaction. It has stamped, so timestamp on it. It has how many transactions. Your bank always gives you score, so whether it's account score or transaction score based on your behavior, your historical behavior. So you need to identify trend, build machine learning trend, and predict it. And the idea is to get to this part here. So I want to know basically if my action is valid or not. So 0 means yes, 1 means a fraud activity is detected by the system. So how do we do it? We actually import the data, and this data will be used to create a trend map. And this trend map, I will store it in memory. Remember, I am interested in speed. And one way to do it is basically to handle as much data as possible and use it for prediction. And the actual code to write it here is kind of like looking at how simple it is. So essentially, you just need 3 lines. You identify your pipeline, you create a new instance, and the platform itself will allow you to scale up or down. You simply add new nodes to your system. And the pipeline is I take all transactions, and then I group based on the score and the time stamp, and I build the trend. So linear regression, if you heard of linear regression, is one way to do it. And after I build the trend, I try to do the prediction. So I want to check if this score is greater than 100, it means the system itself detects some kind of fraud activities within your transaction. So your bank will block this transaction. If not, you should be able to go. And if you're coming from data science background, you don't want to write code, right? So this interface is SQL interface. So everything I mentioned now can be, manipulated and processed in SQL. So this is not normal. It's not ANSI SQL, so it's not standard, but it's the same, very close. And these transactions, it tells me basically for number 8. Let me check numbers here. So for example, the first 4 should be okay for the first 4 transactions, whereas if I want to see what happens in the 5th, probably the bank will, block the 5th based on the model itself. And if you remember from previous side, this even is linear regression model, but at the same time, the system itself should be able to handle multiple models. Obviously, you want to make sure that you have infrastructure. So for example, you have different nodes. You deploy 3 machine learning algorithms on one node, other 3 if you have 6 in total. And then basically you want to make sure you update your scores in real time. So if this node has a better performance or has better prediction, you might be able to switch it into the production and deployment. And the final slide before I finish is the Hazelcast community. So this our platform is built on open source, so we are very active online. If you scan this, if you have any specific question about how you can, have any problem with the platform, our engineers and PMs are available on the Slack community. We do live streams every week. We have live stream on Twitch just to go through some examples and show you how you can implement it. We do physical meetups, so if you would like to have like face-to-face meetup, we can do this, or even technical blocks where we go through some real use cases, how you can implement it. And finally, also we have a program, just like if you're good at Hazelcast, you probably want to join the Hazelcast here. It's kind of like recognition for your contribution to the open source community. With that being said, I think I am finished and I'm open for questions. Thank you. So feel free to ask any question, so whether it's related to my presentation or not, in terms of the machine learning part of the high performance, or even how you can scale applications. So any questions is welcome.
Hello? Yeah.
Hi.
So you mentioned in one of the slides that one of the inputs of your machine learning was the weather. What was the craziest input or the strangest input that you ever had on a project, if you can tell?
So we recognize between like a development side, so where you can develop the model, and deployment side. One thing to keep in mind is you need to be dynamic. In terms of machine learning, it's called features. So features essentially kind of like description. You don't know what features exist simply because these change over time. So for example, if you say, I want to track some features from my bank account, so you probably are interested, I don't know, bank account, bank balance, how long you had this bank account, how many transactions you do online, how many transactions you do it offline. So everything I mentioned is called feature. And this is like a repetitive. So for example, where around the world you access your bank account. So this is like details in terms of, for example, I don't know, the weather here or the weather in the UK. So for example, if I get a transaction from your bank account and this transaction just happened geographically to be in, I don't know, let's just say in Porto, right? So I know temperature is 20 degrees outside. If your mobile has feature to track this and your bank account, which by the way, I don't know your bank account, most bank accounts track this information. So if they can track the weather information from you, and if it wasn't you somewhere in the UK where the temperature is like 8 degrees, for example, or even like, I don't know, Iceland, which might be like even like, colder. So that gives you conflict, right? So even the transaction happens from Porto, but there is some kind of contradictions or conflict because the weather, data coming from Porto is not the same. It should be like 20 degrees, not 8 degrees. So this will flag a, fraud activity in your account. Obviously, like one example here about saving time is reducing false positives. If you check, like for example, if you have two accounts, those people who are here and have multiple accounts know you have definitely, this is for sure, you have favorite bank account. I can guarantee your favorite bank account is the flexible bank account or easy to use bank account. Why? Because they try to reduce false positives. So they don't want to block you from using them essentially. So some bank accounts take it to the extreme. And yeah, you want to make sure that whatever you do to reduce this false positive. So that's another example where it is important to make sure not only to detect fraud, but to detect it right. So you don't want to, detect a non-fraudulent as fraudulent activity. Okay. Other questions? So I would say I'll be staying outside. If you have any question, feel free to drop by. We can have a chat, whether on your application or Hazelcast. That would be great. Thank you. Can you just say hi to my boss? Always ask for where I am now. Thank you. So just as proof, I was in Porto, basically not doing tourist outside. Thank you.